Hi. Today we're going to talk about describing distributions with shape, center, and spread. Today we're just going to talk about shape and center, and in our next lesson we'll cover the spread part of it. So descriptions of a distribution of quantitative data include shape, center, and spread, as well as any unusual features such as outliers, gaps, clusters, or multiple peaks. Whenever we make a graph of a set of data, we want to recognize and describe its distribution. To help remember how we describe a distribution, remember your SOCS. SOCS, which stands for shape, outliers, center, spread. We usually do them when we talk about them. We usually talk about shape first, then center, then spread, and then any unusual features or outliers. But it wouldn't make a cool word to put the O at the end. All right, so shape. Whenever we make a graph, and we've now learned how to make a bunch of different graphs, after we've completed the graph, we want to talk about the shape that the graph takes on. And there are four major shapes that we will talk about in AP Stats. The first is called symmetric, and you can see that one here. So symmetric simply means if you cut it in half, it looks pretty close to a mirror image on both sides of the line. Now notice with this blue graph, it is not exactly symmetric. It is not exactly a mirror image on either side of that red line. But in real data, it's never going to be perfect. Okay? So we would consider that graph to be symmetric. We're going to be dealing with that symmetric shape a lot in AP Stats. The next graph we move to the right is called skewed right. This one is another one we'll see a lot of in stats. Notice it's not symmetric. If I cut it in half, one side is really big and one side is really small. Okay? When that happens, we have a skewed distribution. And we always name the skew towards the side of the graph with what we call the tail. This is the tail of the graph, and since that tail is on the right, we would call this skewed right. Some textbooks call this also a positive skew, because if on a number line, the positive numbers would be to the right and the negative would be to the left. So positive skew means skewed to the right. Okay? Things like income, value of a home, that kind of thing are skewed right, usually. Then we have bottom left here, skewed left. And this is just the opposite of skewed right, obviously. Again, if you cut this in half, you'll notice there's a ton of data over here and not much over here. Okay? The tail of this one is to the left. So this one is skewed left. This would be the tail. Okay? And again, we also can call it negatively skewed. Things like GPA at Jefferson is skewed left. Most people have really high GPAs, and then there's a few that have, the number of kids that have lower GPAs is less and less and less as it gets lower. So there are many things that in life are skewed left. The fourth shape is bottom right here, and that's uniform. And in a uniform distribution, it's basically a flat, all the bars in the graph are basically the same height. Notice on this one, again, because it's real data, they're not exactly flat, but close enough, okay? Another thing you might notice on this one is that it is, of course, symmetric, too. Basically, you could fold it over and it looks about the same, okay? So that's uniform. Another way we categorize graphs are by the number of peaks there are in the graph, okay? And you can see in this symmetric graph that there's really only one peak, or one highest point, okay? When that's the case, we call it unimodal. Think unicycle has one wheel, unimodal has one mode, okay, or one peak. Graphs that have two peaks, like if you look at this one, there's one peak and then there's another peak. That's called bimodal. You can think of bicycle has two wheels. This one has two peaks. If there are many different peaks, we would call it multimodal. Okay, but most data that we're going to look at are going to end up being unimodal or bimodal. You'll notice on this one on the left, I put the word symmetric. When it's unimodal symmetric, that is a special family of graphs called bell-shaped curves, and we're going to be studying those in great detail. Okay, so unimodal, symmetric, those are going to be big ones for us right here. Okay, so that is shape. I'll show you a couple more pictures here on this next slide without drawing extra lines. This is a graph of NFL salaries. It's from 2015. Okay, so it's a little older. But if you look, the x-axis is NFL salaries in millions, and then this is frequency of NFL. That means how many players in each one. Notice that most players, earn between $1 and $5 million a year, and then it gets to be fewer and fewer as we move out to the right. So this would be skewed right. So salaries is one variable that is often skewed right. Okay, in the same, basically in the same field. Here's another graph. This is 3,226 babies that were born, and this is a graph of how much they weighed at birth, and the weight is in kilograms. You can see that this distribution is symmetric, and we'd actually call it unimodal symmetric because it has one peak in the middle. Okay, so things like weight or birth weight in any species ends up to be this unimodal symmetric distribution. So we're going to end up seeing that a lot. Here's another example. This is the percent of daily change in oil prices. So like from one day to the next, how much does the price of oil change? And it's done by the barrel. You can see that most of the time the change, like in this highest category, is very small. That's not 2.9%, that's 29 thousandths of a percent increase. You can see most days, it's almost between 800 and 900 days here. The price doesn't change very much. And very few times does it change a lot in a positive direction, and very few times does it change in a negative direction. This again is unimodal symmetric. Okay, so those are some of the shapes we're going to see. And as you can see there, actually, there's a ton of real life data that will end up being those shapes. So when we graph data, the first thing we'll do is we'll talk about the shape. Hopefully it'll be one of the ones we recognize. The next thing we would talk about is the center of the data. And the center of data describes a typical value in a set of data. So if you had to represent the entire set of data with one value, what would it be? Okay. In statistics, we use three measurements, the mean, the median, or the mode. I would say the mode is not used very often, but we will discuss it and how it fits into everything. But the typical measures of center are the mean and the median. And it depends, the shape of the graph will determine whether we use the mean or the median as the center. So let's talk about the mean first. All of you know the mean is that's a special name for the average of a set of data. Okay, if you look at this little graphic right here, okay, in statistics we have two different means. Okay, we have this symbol, which is pronounced X bar, and that is the sample mean. Okay, if you remember back to the first day, we talked about populations and samples. A sample is a small group, remember, that we try to use to represent a large group. So if we're only talking about a few members of a group, we have to use the sample mean. And then we have a population mean, which is, of course, if I have an entire group of people. Okay, and then when we have a population mean, we use the symbol, this is pronounced mu, and it looks like a cursive U, and that stands for mu, and that's the population mean. Notice they have the same equations. You add up all the data, and then you divide by how many pieces of data you have. Okay, but we do need to be careful. Like if I was talking about every student at Jefferson High School, that would be a population mean. If I was talking about just our AP Stats class at Jefferson, that would be a sample mean. Okay, so it depends on the group of people you're looking at. Here's the cool thing though, over here to the right. The mean works best for data that is unimodal and symmetric. So from that previous page, when the graph looks like this, that is when we would like to use the mean, okay? And what we're going to find out is the mean is located right in the middle, which is pretty cool. When data is skewed right or left, the mean gets distorted in the direction of the skewness, okay? So like in that NFL salary example earlier, that was skewed right, and you had a couple people making so much money. When you average those really high salaries in with the rest, it pulls the mean towards them, okay? So we need to be careful in skewed distributions. We don't want to use the mean as our measure of center. So how would we find the mean? Well, this is our data on states visited. We've looked at this in our stem plot unit. So we're going to find the mean of our states visited data using our calculator. So just like we did with a histogram, you'll use stat and edit to enter the data. Okay, so you hit stat, then you hit edit, and then you put the data in list 1. You might still have your data in your calculator. If you do, that's great. Then we can just move on. But here are the screens. So you'd go to stat and edit. That's where you'd put your data. And then once your data is in, you'll hit that stat button again. So you're looking at this screen to the left here, this first one. And you want to move that top cursor over to calculate. So that calculate's highlighted like it is in the second screen here. So that calculate should be highlighted. And then when you hit enter there, you'll get this third screen. So hit enter on this screen. And then the third screen, you'll see a list possibility. And that is where you want to make sure you name the lists where the data is located. So our data was in list 1. And the frequency list, you can just leave blank, don't put anything there. And then the one you can't see here is the button you hit to actually have it find the mean, okay? So you'd hit enter once you have list 1 set up. If you're on a TI-83 calculator, this screen will look like this. It'll go one var stats, and then I'll have a blinking cursor, and you can just hit enter again and it'll do it for you, okay? Then you'll get to this bottom left screen, and you'll notice at the top of it, there's the mean. You can see it, they label it as X bar, and it's about 14.3. So that was the average number of states that we visited in our class, or this class. You'll see there's some other information here. This is how many states total we visited. This is the total states squared. Like if you squared each number of states and added them up. These two calculations are called standard deviation, and we're going to get to those later. Those are measures of spread. N is how many people were in our data set, so there were 33 pieces of data. And then I'm going to go over to the next screen, which is what happens when you page down. And here you'll find 5 numbers, which are called the 5-number summary, where it has the minimum, the first quartile, the median, the third quartile, and the max. So all of that comes from doing this one variable stats command. So that command is going to come in really handy. We're going to use it a lot, okay? And there is a video on the first homework assignment, or on the homework assignment for today, where you could watch somebody do this on the calculator on video, okay? So that's how you find the mean. Next, we'll talk about the median. The median is another measure of spread. The median of a data set is the middle value of the data when it's in order. Okay. When the number of data points is even, then the value for the median of a data set is the average of the two middle values. And I'll show you that in the example here. So sometimes there's an actual middle value in the data, and sometimes we have to compute it ourselves. The median divides the data into 2 equal parts. 50% of the data is above the mean, and 50% is below the mean. That's a very important definition to understand, okay? The median divides the data into 2 equal parts. In a symmetric distribution, the mean and the median will be approximately equal, which is cool. So that means if we have a unimodal symmetric distribution, the mean and the median will be about the same, and they'll both be right in the middle of the graph, which is cool. The formula at the right is for the location of the median. The result is how far to count in from either end of the data when it's in order. So this is a position formula. Okay, it doesn't tell you the median, but it tells you how far to count in to find the median. Okay, so let's find the median of the sets of data below. We're looking for the middle value. So in this one, it's pretty easy. The middle value is 3. Okay, that'll happen when there's an odd number of pieces of data. The middle value will be an actual value in the set. In the second grouping here, notice there is no middle value. Okay, there's 2 values here, 2 values here, and the middle is in between 2 and 3. When that's the case, we just add 2 plus 3 and divide by 2. So you find the average of those 2 points. So the median would be 2.5. So when there's an even number of data points, you're going to have to calculate the middle of the 2 middle values. When there's an odd number, you can just find the odd by counting it. Now let's see how you use that formula to the right. Okay, notice in this group there's 5 pieces of data. So in the formula over here, I would put in a 5 for the n. And then I would add 1 and divide by 2, which is 6 divided by 2, which is 3. That tells me to count in 3 pieces of data to find the median. And I could count from either side. I'm going to switch to yellow so you can see through it. I could count from this side, 1, 2, 3. So 3 is the median. Or I could count from this side, 1, 2, 3. 3 is the median. Okay, so this 3 means that the median is the third number in the data set. Okay, for the second example, there's only 4 pieces of data, so I would do 4 plus 1 divided by 2, which would be 5 divided by 2, which tells me it's the 2.5 piece of data. And that lets me know that it's going to be in between 2. So I'd count 2 in, and then a half more, which would be in between 2 and 3. So then I would take the average of 2 and 3. Okay. So this 2.5 tells you the position of the median. That's going to be in between the second and third pieces of data. Okay. Now, your calculator can find medians as well. If you go back to one variable stats and page down, you can find the median of our states visited data above. We're going to record both of these right here. So I'm going to go back a slide. So I went back to the previous slide and I found that the median of the set of data of states visited was 11. And I also wrote down the mean, which was, if you remember, 14.3. Okay. Now, down to the right here, this is a graph of all of our states visited data. I stole that off of the histogram lesson. So remember the graph of our states visited. That is skewed right, obviously. We have a tail on the right, so we would call that skewed right. And notice that the mean has a higher value than the median. Up here, the mean is 14.3, the median's only 11, okay? This is always the case in a skewed distribution. The mean will be pulled in the direction of the tail or the skew, okay? That's why in this one, the mean might be out here somewhere at 14.3, and the median might be in here somewhere at 11, okay? And those are just estimates, but that's what happens. The mean will always be pulled a little bit to the right. Remember what we said earlier, that in a symmetric distribution, the mean and the median would be about the same, okay? So this is one way you can tell if a distribution is skewed, is the mean, like in this case, higher than the median? And that's what happens when the distribution is skewed right. If it was skewed left, then we'd expect the mean to be lower than the median, okay? So for this reason, this last paragraph here, we always report the median as the center of skewed data. It is a better measure of a typical value. Remember, 50% of the data is above the median, and 50% is below the median. That's a typo, sorry. Oh, that's where the E went. Okay. Now, I wanted to mention this. When we were in that one variable stats part of your calculator. We mentioned that if you page down, you could find what's called the 5-number summary, okay? The 5-number summary are the quartiles, which divide the data into 4 equal parts, okay? So you can see there's a Q1. The median is considered Q2, or the second quartile, and then there's also a Q3. So these 3 numbers are the medians, or are the quartiles, okay? The quartiles divide the data into 4 equal parts. So you could think of like Q1 is here, median is here, Q3 is here, and there'd be 25% of the data below Q1, 25% between Q1 and the median, 25% between the median and Q3, and 25% above Q3. And remember, the median divides it into 50-50 on both sides, right? So the first quartile, Q1 is the median of the first half of the ordered data. The third quartile is the median of the second half of the data. Okay, and Q1 and Q3 form the boundaries for the middle 50% of the values in a data set. So for our states visited, the minimum was 1, which means that was the lowest number of states visited. The first quartile was 7, which means 25% of our class saw below 7 states. The median was 11, which means that half the class saw less than 11 states. Third quartile was 18, which means 75% saw 18 or less, and of course 25% saw more than 18, and the highest value was the max. So we know that 25% of our class saw between 18 and 50 states. Okay, and we'd also know that 25% of our class saw between 7 and 11. Okay, so that 5-number summary can tell us a lot. Okay, and it's all related to the median. The last measure of center that we're going to talk about is the mode, and this is the one that's used the least frequently, but we're still going to talk about it. So the mode is the most frequently occurring piece of data. So in this case, this little set of numbers over here, there's 3 6s, so 6 would be the mode. Okay, it's possible for a data set to have more than one mode. Like in this case, I've got 2 2s and I have 2 4s. So they would both be considered the mode, okay? The mode is simply interesting because sometimes it's interesting to know which piece of data occurred most frequently, okay? This will help a little bit with an explanation about the mode. Comparing the mean, median, mode in distributions. Notice in a symmetric distribution in the middle here, the mean is equal to the median and it's equal to the mode and it's right in the middle, okay? Where you find a mode in the graph is the highest point. So the highest point in the graph is the mode. So if you look at a skewed left distribution, the mode is right at the peak of the data, so where the data is at the highest point. But because it's skewed left, the mean gets pulled in the direction of the tail, okay? So notice the mean is a little bit lower than the median. So in a skewed distribution, this is how it will go. The mean will be the lowest value, the median would be next, and the mode will be the highest. In a skewed right distribution, notice that the mean again got pulled to the right, okay? And then the median would be second, and the mode is obviously the highest point. So that's an important distinction to make. In a symmetric distribution, the mean and the median are the same and they're right in the middle. If it's skewed right, the mean is getting pulled to the right by these really high values, okay? And in a skewed left distribution, the mean gets pulled lower than the median because of the really low values. Here's another example. This one is unimodal symmetric. The mean, the median, the mode are all the same. Here's a bimodal distribution. So there's 2 peaks, so 2 modes. But notice that the distribution is still symmetric, which means that the mean and the median will be in the same spot. Okay? Anytime the distribution is symmetric, the mean and the median will be in the middle. Our last one, this is a uniform distribution. And in a uniform distribution, remember, all the bars are the same height, so there's no mode. Okay? But because it's symmetric, the mean and the median will still be in the middle. Okay? So in a symmetric distribution, the mean and the median will be in the middle. And in a skew distribution, the mean may be higher or lower than the median depending on the direction of the skew.